Neural machine translation for extremely low resource African languages, a case study on Bambara. We'll talk about the Bambara language, the data collection and preparation process, the neural machine translation development, our results, and the conclusion. The Bambara language. Bambara is a tonal with rich morphology. Although primarily a spoken language, several competing writing systems exist. One finger cannot lift a pebble, and standard Bambara will be Bologna Kilintesica Beleta. When you write it in French like using only French alphabets will be Bologna Kilintesica Beleta. And the correct script also exists. So for the data preparation, automatic alignment was not an option because the task was more complex and tedious. So we did it manually using a custom aligner where we have the Bambara, French, and English. And these comments go to the next item one at a time, and this to the previous one at a time. And this button moves the whole three at a time, and this moves it to the previous one. This aligns Bambara, French, and English. This button aligns Bambara and French. This aligns Bambara and English. And this button saves it, and this continues saving it by appending at the end of the file. The data that we work with is within the same Mali French, English, Bambara French, Bambara English data, where we align the Bambara part with the French and English part, and we split it into training data and test sets. We also have the Docotoro data that we use for bug translation and multilingual, but did yield interesting results. But we'll talk about that later. So we have also the Wikipedia monolingual data about 488 Bambara sentences covering a range of topics with a preponderance of articles related to Mali that we use for our training with the translation model and the multilingual model, but it suffered from domain mismatch as well. The neural machine translation development, we use our GUI NMT built upon PyTorch by Kratzer and all, 2019. So we had 6 layers for attention hits per layer. Transformer size, layer size was 124, 1024. The hidden layer and the embedding sizes were 256. We train all the models on 120 epochs with 124 tokens per page. So for the evolution, we use Blue and CHRF for development. We also carried out a small-scale human evaluation for the best model on 21 sentences selected at random. So for preprocessing, we ignored all the items that didn't have any other correspondence in the other languages. And we dealt with a case where we had a slash separating pronouns, like he, she was born in Bamako. Before we have a LOL, any Bamako, and there's no sound conflict. Abanyana Bamako sound, by killing Bamako and Bisaran Shady. So in Bambara, we see that there's no specific city about the pronouns, and after we split them with the correct grammar, along with the Bambara translation. So we'll deal with cases where we have one linear cannot lift a table, where it is there is an explanation to help explain, conveying the meaning of what it means. So we pick out the parentheses and we remain with only the literal meaning of the sentence. And for proverbs, we have like proverb meeting after a long time is better than hearing a deaf announcement. So we take out the proverb identifier so that we have a normal sentences without anything to mess up the model. So in during machine translation, we considered the input units at character, word, and byte encoding level, both with 500 and 1000, and along with the dropouts. So the best performing models were the ones using the byte encoding model. And for our back translation and multilingual training models, we didn't see any empirical improvement for those due to domain mismatch. For human evaluation, 1 and 3 are about the likelihood of are about the how the sentences are conveyed, the translation conveyed some plausible and related things to the source. And 2 and 4 are things that are direct, plausible direct translations of what in those sentences. And 7 where most people would be able to get it at a minimum, the gist of the source. So the evaluators were two people with college level reading for both French and English who have received primary education in Bambara as well, so they know how to read and write in Bambara. In conclusion, to the best of our knowledge, this is the first attempt at translating to and from Bambara, achieving acceptable translation quality. So for the success of future work, maybe the more general domain evaluation set will be needed, and an automatic alignment will be key in being able to gather more data, diverse. And we plan also on utilizing crowdsourcing to advance the development of the NMT.